So I have here an example of binomials containing radicals. Binomial, two parts, another binomial. We're going to multiply them. 5 times 2. 5 times root 3. Negative root 3 times 2. Negative root 3 times positive root 3. At this point, I want to combine like terms. Do you see any like terms? Right here. And I want to simplify that radical. So, rewriting 10. 5 root 3, take away 2 root 3. 3 root 3. Negative square root of 9, negative 3. Oh, look, more like terms. Plain old numbers. 10 take away 3, 7, plus 3 root 3. And there is your answer. Okay, let's try another one here. 4 root 2 plus root 3 squared. First thing to do is to write that twice. Now, do the same thing we did with this binomial. 4 root 2 times 4 root 2, 16 root 4. 4 root 2 times root 3, 4 root 6. Root 3 times 4 root 2, 4 root 6. Root 3 times root 3, root 9. Now simplify all of the parts. This becomes a 2. 2 times 16, 32. Add these two like terms. 8 root 6. Simplify this radical. Plus 3. Add any more like terms that you have. 35 plus 8 root 6. Now, there is a way to do this without writing the binomial twice. If you learned how to do these in your head in Algebra 1, you can square the first term, which would be, so let's do it down here. If I square the first term, I get 16 root 4. I square the last term, I get root 9. In the middle term, I multiply these two and double it. So 4 root 2 times root 3 is 4 root 6. Double that, which means times it by 2, 8 root 6. If you want to use the shortcut method, you can, and notice that this part is pretty much this part here, except for you have to do a little simplifying. So either method works, just be careful. All right, we're getting a little harder here. Binomials containing radicals and involved in fractions. This one, when you have a radical in the bottom of a fraction, you know you're not supposed to be able to leave that as an answer. But to get it out of the bottom of the radical is pretty hard, because if you think, oh, just multiply by root 15, when you do that, root 15 times this clears the radical, but then you have 4 root 15 over here. So that doesn't work. And then if you try it again, you end up with the radical back on this side. So what you have to do is multiply by a binomial that's called the conjugate of that binomial. And again, you're multiplying the top and the bottom of the fraction by exactly the same thing, which is in essence multiplying by 1, so not changing the value. So what do you think the conjugate of this is? 4 plus root 15. 4 plus root 15. And if you remember when you were doing binomials like this, whenever the two binomials were exactly the same, one with a plus and one with a minus, the middle term disappeared. Because if you look at it, root 15 times 4 is negative 4 root 15, and this 4 times root 15 is positive 4 root 15, so it disappears out of the problem. So I'm just going to write down what I need here. 4 times 4 is 16. Root 15 times root 15 is minus root 15 squared. I could have written 225, but the square root of something squared is that something. So in this case, it's 15. So the bottom of this fraction is 1. 16 take away 15. The top of the fraction is 1 times that. 1 times 4 plus root 15. And that's the answer. You don't really need the 1. All right, so let's try the next one. Do you know what the conjugate would be? If you think you know how to do this, stop the video, try it yourself, and then restart to see if you get the right answer. The conjugate in this case is root 2 minus root 3. Looks the same, the only difference is the sign in the middle. Do the top by exactly the same thing because remember, we're multiplying by 1. We're not changing the fraction, we're making it look different. Okay, here we go. We know there's no middle term. We chose this binomial so that that would work. So let's do root 2 times root 2, root 4, minus root 3 times root 3, root 9. Now some of you might be good enough at these that you're comfortable just writing a 2 and a 3 there. And if you do, that's fine. 2 minus 3 is negative 1. So this fraction has a negative 1 on the bottom. And on the top, that one's a little more difficult. Root 3 times root 2, root 6. Root 3 times root 3 minus root 9. Let's rewrite that. Root 6 cannot be simplified. Root 9 I know is 3, and the whole thing is over negative 1. That could be the answer. Another thing you could do for this answer is divide both of these by negative 1, so we would have negative root 6 plus 3. This is probably a better answer. Somebody else might want to write it 3 minus root 6. That's also an acceptable answer. So you need to learn to recognize if you do get this kind of answer that you could write it in another form. You're also going to see some function problems in this section. Here we have f of x equals x plus 1 over x. Find f of root 3 plus 2. The key to doing these is figuring out what is the substitution and where does it go. This is the substitution, and where does it go? Every place there's an x. So I mark up my diagram a little bit, and now I'm just going to rewrite it. F of root 3 plus 2, every place there's an x, I'm going to put root 3 plus 2 equals, there's an x there, so I'm going to put root 3 plus 2, I still have that plus 1. On the bottom, I'm going to replace that x, root 3 plus 2. Now I'm going to add like terms. Root 3 plus 3 over root 3 plus 2. Now it looks like I'm finished, but then I remember no radicals in the bottom. So I need to multiply this by the conjugate. Do you remember what the conjugate is? It's a fraction. It's root 3 minus 2. Root 3 minus 2. I like these in parentheses. So we do that. And now I'm going to do the multiplying. We'll put the answer over here. Root 3 times root 3. Root 9. Root 3 times negative 2. Minus 2 root 3. Again, if you know the shortcut, I suggest you use it. 3 times root 3 plus 3 root 3. 3 times negative 2 is minus 6. I can add like terms here, so I get, and that becomes a 3. So 3 minus 6 minus 3 minus 2 root 3 plus 3 root 3 is 1 root 3. We don't need the 1. And on the bottom, remember the shortcut we learned before? Because these are exactly the same, 1 plus and 1 minus, there's no middle term, so I'm just going to write the first term, root 9, and the last term, negative 4. Root 9 is 3, so that's 3 minus 4. You know what that is, right? Negative 1. Then I can divide the negative 1 here, so I get 3 minus root 3. Final answer. Those are not as hard as they look. The key find the substitution, note where it is, and then just replace or substitute. These are the parts that I substituted in to where the x's were. And then I just solved that problem. You can do those.